Hello, welcome to day 14 of Advent of Code. In today's challenge, we have list of robots, guarding robots, and each robot has its own starting position on the grid and also the velocity that will be applied each second to the position. So after second one, the position will change to 3 and 1 for X and Y position. If the robots move outside of the map, so for example, if the Y becomes negative, it will teleport to other side. So Y would be the row here, but it's not there, so it will teleport to the last row and continue its movement. After a certain amount of seconds, in the example it's 100, we need to divide the grid to 4 quadrants and count the robots in each quadrant. And at the end, we need to multiply the counts of robots in each quadrant to get our final answer. Robots that appear on the intersections, like here where the empty space is, will be dropped and not counted. So we don't count the robots on the intersections. For the part 2, the robots assemble to a picture of a Christmas tree, and we need to determine how long will it take for the robots to create picture of Christmas tree. So for the parsing, I go over each line with the robots and parse it to a dictionary with 2 fields. So it's S like start position and V for velocity, and inside of it I have another dictionary for X and Y positions. I save the values here, and that's it for the parsing. For the part 1, I go over the list of robots I parsed before. Then I plug the robots inside the simulate movement function with an amount of seconds. And this is this function, simulate movement. I go over the range of time. So basically it will be range of 100. And I update the position every time, check the condition if the robot would be outside of the map, and calculate the position it should be placed in. At the end, I return the updated position after the amount of seconds. So this is enough for part 1 to calculate the positions. And then I go and create a list of quadrants, get the middle of the width and middle of the height, and go over the computed positions and check the conditions under which each position fall into, and then append it to the right quadrant. Then I go over the quadrants, take the length of each quadrant, so how many robots are in the quadrant, and multiply it. At the end I output the value, and if I do so, it's pretty quick. I get the right answer. For the part 2, I slightly improved the simulate movement method because I don't want to go each time over the range of 1, 2, 3, 4, and 5, and so on seconds. I want to cache them, so I have the result already in place, and I just calculate the next following update for next second. So I implement this save last parameter here and the cache dictionary, which stores the positions for each robot and its output value. So this happens here. I compute the key, which consists of the position, start position X and Y, and also the velocity for X and Y. I check if the save list is true. Then I check if there is already entry for the last key, and if it's true, then I update the start positions and set the time to 1 to update it. And at the end, after running this for loop with range of 1, I save the result to the key, and that's it. Then here for the part 2 I iterate over a range of 10,000. It represents the seconds. So I try to brute force the solution basically. I simulate the movement for each second. So it could be second 1, second 2, and so on. And I set this parameter to true to save the previous results to reduce computing of the movements, unlike part 1. So I simulate the positions of the robot. So this is the same as part 1. But beforehand I also create image. So this is a array of arrays, and it has this value like the dot to represent empty spots, and I update this image with hashes to represent the robots. And when the image is updated by the position of robots, I render the image to a single string and check for place where hashes align in at least 8 hashes in line. So if this is the case, it may be that this rendered image is the Christmas tree we are looking for. So if it's the case, I print the rendered image and I print the count of seconds for it. So if I run it now, it takes quite some time, but now I have some output and it looks indeed like a Christmas tree, right? And I checked the answer. This is the right answer. So pretty straightforward way to compute this. So this is pretty much it for today. Let me know in the comments how you approach the part 2. For now, goodbye and until next time.